See here, applying Kirchhoff first law or junction law to a bit. See the junction law. Here how many junctions are there? 4 junctions. A, B, C, D. Now the first we can apply the junction A. At a junction, A. See the junction A. So what is the principle for that junction? For the statement, the sum of the current is enter into the junction is equal to the sum of the current is leaving to the junction. Now at A point, how much of the current is entering by there? The I current can be entering. The leaving to the junction, what is the other? I1 plus I2. This is the sum of the current is entering the junction is I, and leaving to the junction, what is there? I1 plus I2. This is considered the equation number 2. Now the similarly we can apply the at junction B. At a junction B point. The junction B point. Now observing here the junction B point, the which is the entering is there? I3 and I4 can be entering to the junction, and leaving to the junction, how much is there here? Only for the I. Then we can write here the sum of the current is entering to the junction I3 and I4 is equal to the leaving to the junction. How much of the current is there? I. This is considered the equation number 2. Next we can apply the at junction C. At a junction C. Now at junction C, see how much of the current is entering is there? Only the I1 current can be entering. I1 is equal to, and leaving to the junction I3 and IG. Then we can write sum of I3 plus IG is the leaving to the junction. Now this is considered the equation number 3. Now next, the last junction at junction D. At junction D. Now observing at junction D, now here how much of the current is entering is there? Here the IG and I2 is the entering to the junction, and leaving to the junction, what is there? Only for the I4. Then we can write here the I2 plus IG is equal to how much is there? Here the I4. This is considered the equation number 4. See, this is the Kirchhoff first law applying to the 4 junction. The next we can apply the Kirchhoff's second law. Applying Kirchhoff's second law, or what is called as voltage law. Voltage law, or also is called as what is the loop law. See, applying the Kirchhoff's second law or voltage law or loop law. Loop means we take the closed circuit. See, observing here here in this circuit we have the 2 loops here. The first one A, C, D, A. This is the one of the loop. What is this? A, C, D, A is the one of the loop. And another one, what is there? C, B, D, C. This is the second loop. Now apply the second. See, what is the statement for the Kirchhoff second law? The algebraic of sum of the potential. The sum of the potential and EMF R is equal to 0. That is say the Kirchhoff second law. And here there is the some rule. See, what is the rule? When the current and loop having the same direction, we take the negative. In opposite direction, we take in a positive. See, again, once again we can draw. This is the diagram for the take the loop. A loop. What is taken by the A, C, D, A? A, C, D, A is the one of the loop. In the loop, see, observing, this is the A point. This is A point, and it is there the resistance, and it is a B point, and here the galvanometer, and reach this is the another point. See, right, this is the A point, A junction, C junction, and D junction. This is the galvanometer. And here what is there? Here the P, and here is there the R. This is the loop. The current, which is the direction? This is the I1 current. Here the IG current. Here the I2 current. See, this is the loop. Now the first, where we can start at A point. See, here how many potential differences are there? The P resistance having the potential difference is V1. and the galvanometer resistance is there, the potential difference is V2, and the R resistance of the potential difference is V3 is equal to 0. See, the algebraic of sum of the potential difference in a closed circuit is equal to 0. The how many potential difference are there? Here the 3 potential difference. Again apply. From Ohm's law, what we can do, the V is equal to I into R. See, I, how much is there? The I1 of the current. The resistance, see, how much is the P. But observing the loop which is taken by the is in a clockwise direction. And the A point to start in the clockwise direction. The current also same direction. That means we take here the negative. What is taken by here the negative. And next, plus V2. V2 means the current and potential difference. The current and resistance. Current how much is there here? The Ig. Resistance how much is there? Capital G. But observing here the loop also C to D direction, and current will be also same direction. The current will be same direction means what is taken by here? The negative. The positive into negative, what is there here? The negative. And plus V3. V3 is the potential difference due to one third resistance, R resistance. Here again the current into resistance. Current how much is there? The R2. Resistance which is there? R is equal to 0. But observing here, the loop is the going on D to A point, but the current which direction is there? A to D direction. That means the loop to opposite direction. Opposite direction means what is taken by the plus. For the same direction we take in a negative. This is considered the equation number 5. What is considered this in a equation number 5. The next, applying Kirchhoff's second law of loop C, B, D, C. This is the second loop. In the circuit, this is a second loop. Again, we can write here the points. See, what is the point? Is here the C point. This is the circuit will start. The closed circuit will start at the C point. Now is there the resistance, and here the B point, and it's the reverse. And this is the point. Is how much is there? The D point, and the between is the C to D between is connected by the galvanometer. Now write here the direction of the current. Here how much is the direction? Is that this is I3, this is the I4 reverse, and this is the Ig. But the loop where is C to D point. C to D point. Again here the how many potential differences are there? Here the resistance is the Q, S and G. And the Q resistance having the potential difference, and S resistance have the potential difference, and G galvanometer of the resistance also potential difference. That means you take the V1 plus V2 plus V3 is equal to 0. The algebraic of sum of the potential difference in a closed circuit is equal to 0. Again apply the potential. What is the current into resistance? See the current, the which direction is passing is the C to Q, and loop is also same direction. That means we take the minus I3 into Q. And next we can observe the current is the loop is passing B to D direction. This is the clockwise direction. But the current which direction is there? Opposite of direction. Opposite means we take the positive. The current how much is there here? The I4. Resistance how much is the S. And then the loop is moving D to C point. D to C point. This is the clockwise direction. But the current which is there then C to D direction. Opposite direction. Opposite means again we take the positive. Ig into G is equal to 0. This is considered the equation number 6. Equation number 6. This is the applying Kirchhoff first law and applying Kirchhoff second law. And then when the bridge is balanced, when bridge is balanced means when the bridge is the same resistance is there, there is no current can be passing through any galvanometer. When the bridge is balanced, therefore the galvanometer current, galvanometer current Ig is equal to how much is there? 0. Galvanometer current how much is there? Ig is equal to 0. Now this value, this Ig value can be substituted in above equations. When the bridge is balanced, the galvanometer current Ig is equal to 0. This value substituted above equations. From equation 3, because of equation 1 and 2 there is no galvanometer. But in equation 3 what is there here? The equation 3 is that I1 is equal to I3 plus Ig. Now Ig is equal to how much is there here? 0. That is I1 is equal to I3. This is considered the equation number 7. Next, from equation 4. Equation 4, what is there here? The I2 plus Ig is equal to I4. I2 plus Ig is equal to I4. Then Ig is equal to what we can write here? 0. 0 is negligible. I2 is equal to I4. This is considered the equation number 8. Next, from equation 5. From equation 5. From equation 5, what is there here? The minus I1P minus IgG plus I2R is equal to 0. In this one, Ig is equal to how much is there? 0. Minus I1P minus 0 into G plus I2 into R equal to 0. Now this total 0 into something 0. This total term can be 0. And this is taken this side minus. The minus minus can be gets cancelled. Then we can write the I1P is equal to I2R. This is considered the equation number 9. From equation 6. From equation 6. From equation 6, what is there? Minus I3Q plus I4S plus Ig is equal to 0. Then we can have the minus I3Q plus I4S plus Ig 0 into G is equal to 0. Again, this is 0 into something, this term can be 0. And I4S taken this side, this is a positive, taken that side negative, and that negative and this negative can be cancelled. The remaining what is there here? The I3 into Q is equal to I4 into S. This is considered the equation number. Equation 9 divided by equation 10. Equation 9, what is there here? The I1P is equal to I2R by I3Q is equal to I4S. This is the equation 9. This is the equation 10. But we know that from equation 7 and 8. From equation 7 and 8. What is there here? The I1 is equal to I3 and I2 is equal to I4. Then this value can substitute. I1 is equal to how much is there here? The I3. P by I3Q is equal to I4 S by, I4 R by I4 S. See, I2 is equal to how much is I4. Then we have the cancel. See, I3, I4 gets cancelled. Then what is there here? The P by Q is equal to R by S. See, this is the principle of a Wheatstone bridge and comparing of the four resistance. What is there here? The P by Q is equal to R by S.